Greetings of the day, dear students. In this video, we are going to discuss about the biasing of the field effect transistor. We will see what are the different biasing methods we are having, right? By the time we complete this video, we will discuss a separate power source method and a self bias method, source bias method, and voltage divider bias method in order to do the biasing for the field effect transistor. With respect to the biasing, it implies that application of the DC voltage in order to maintain the voltage and current. The application of DC voltage can be treated as biasing. For that sake, if you recollect the field effect transistor diagram, just I will show you here. This is the source. This is the source terminal. This is the drain terminal, and this is the gate terminal. Three terminals we are having as we discussed earlier. One is the source terminal, drain terminal, and another one is the gate terminal, right? Here four types of biasing is possible. One is the using a separate power source, right? VGG as shown in figure A, and another one is the self bias as shown in figure B. Some part of current, the drain current itself will be used to bias the circuit, and also a source bias circuit, and using a voltage divider we used to apply the biasing for the circuit. Dear students, if you observe the circuit B, this is a self bias because the VGS is obtained. The VGS bias is obtained from the flow of JFET's own drain current ID. Because of the flow of the drain current ID through RS, the drain current flows through this resistor RS, right? Using that the biasing will be applied. Under that scenario, the VS, the source voltage, is given by current flowing through drain current into the resistor connected at the source side terminal. At the source terminal, the RS is the resistor connected. So VS will be equals to IDRS, and obviously VGS, gate source voltage will be minus ID times RS. And here the important point is the gate is to be kept at as much negative potential as possible to keep it in the reverse bias mode, and also due to the high input resistance or impedance offered by the JFET, the drain current the current through the gate IG will be 0. No gate current flows. IG will be approximately equals to the 0, right? So the gate is to be kept at this much negative potential with respect to the ground. That is very, very important. The gate potential is to be kept at this much negative potential with respect to what? With respect to the ground. Now because of this extra resistor added, which is added to the gate terminal, RG, okay, it is not going to affect any bias. It is not going to upset the DC bias, right? Because no gate current is flowing. No gate current will flow through the through this terminal, right? So here the gate will be at DC ground potential. That is, the gate will be at the DC ground potential, as because no gate current flows through the gate terminal because of its high input impedance offered by the gate terminal. No current flows through the gate terminal, right? Now one more advantage is there. Without RG, what happens is the gate will be kept floating, right? Because of this floating nature of the gate terminal, it is going to collect some charge, and ultimately it is going to cut off the JFET. So because for that reason we have to place the RG, a resistor connected to the gate terminal. Without that, the gate will be simply kept as floating. If it is floating, what will happen? It is going to collect the charge, and ultimately it is going to cut off the JFET. And also the one more resistance, RG, additionally serves the purpose of short circuiting of the AC input voltage, whatever the AC input voltage you are applying at the input terminals, okay, in order to avoid the short circuit, this RG will be, the resistor which you have connected will be helpful. And also if any leakage current is there, in case leakage current is not totally negligible, okay, this resistor will provide a path for the leakage current to escape. Otherwise, what will happen if there is no path for the leakage current to escape, right? It will build up some static charge or voltage at the gate, which will change the bias or even destroy the J effect. It is also going to destroy the J effect also, right? So these are the advantages of having or connecting a resistor RG to the gate terminal. One is it will provide a path for the leakage current, right? And it will not keep the gate floating in air just simply, so that the charge will not get accumulated, so it won't lead to the cutoff, right? These are the advantages we are having. And moreover, whatever AC input we are applying, it will not undergo any short circuit, right? Because of this connected resistor RG to the gate terminal. That much importance is there for this resistor RG, right? Yeah. Now if you observe the figure C, the self bias, the figure C indicates the self bias, right? Resistor RS to obtain the VGS, in order to obtain gate source voltage, that is given by VSS minus ID times RS, where ID indicates the drain current. For example, VSS is given by ID times RS plus VGS. If you apply the KVL, the source side, source, drain, gate, three terminals we are having. This is the source terminal, right? And this is the drain terminal, and this is the gate terminal. Here also, in this figure also, this indicates source terminal, this is the drain terminal, and this is the gate terminal, right? Now VSS will be equals to the voltage of source terminal with respect to the ground. VSS will be equal to the current flowing through the resistor RS into resistor value plus voltage across the gate and source. If you observe this gate, the gate voltage will be maintained at negative potential. Minus is important. Here the source terminal is positive. The source terminal is positive, right? Now this is the gate terminal. Whatever the voltage you measure with respect to the ground, that will be the VGG, the gate with respect to the ground. And now here you can apply some input voltage, whatever waveforms you used to apply, that you can apply across the input terminal, right? Yeah. Now if you observe figure D, this shows the voltage divider. Voltage division rule we have to apply in order to obtain the gate source voltage. Finally, in JFET, what happens is, our focus is to control the gate current, drain current, the current flowing through the drain. It will be the some function of voltage. The voltage is across the VDS. It will be the function of drain source voltage, VDS, right? It will be the function of some voltage, and moreover it will be not linear, as in the case of transistor. In JFET it won't be linear. The relationship will be non-linear between the drain current and the voltage. It is not linear, right? That point also we have to remember. Now if voltage divider bias, in this case what happens is, dear students, the voltage V2 can be obtained as VGS. This voltage V2 will be equals to VGS plus the current flowing through the RS, that is the drain current. Via gate it flows to the RS, right? The current flowing in the RS into RD, the current flowing in the RS into RD plus VGS will give us the V2. Obviously the gate source voltage will be V2 minus ID into RS. Now what could be the value of V2? This value of V2 will be total voltage VDD into opposite same arm resistance R2 by total resistance R1 plus R2. So in the place of V2, if you substitute VDD is the voltage across the drain terminal, right, with respect to the ground. VDD, VDS, voltage between the drain and source, VGS, voltage between the gate and source, right? Yeah. Now VDD into R2 by R1 plus R2 will be the value of V2. This is the voltage divider bias. So VGS is given by VDD into R2 by R1 plus R2 minus ID into RS. Like this, we are able to bias the JFET. So application of DC voltage in order to control or obtain the values of voltage and current is known as biasing. The JFET offers high input impedance. The gate current will be or almost equals to 0. If any sort of leakage currents are there, those are to be provided a path with the help of RG for its flow, right? Yeah. If RG is not there, it is simply the gate terminal will be floating in the air. If it is floating, some charge will get accumulated. It leads to some gate current, or it may destroy the or cut off the JFET. That will be the use of this RG. Like this, these are the different biasing techniques we are having, right? These diagrams, variable names, and their polarities, current directions, all those things are important. Okay, thank you.